So we've just done a coordinate, an answer that intersects at a coordinate. We're going to test out this one now. We have three equations, same idea. Just by efficiency, I'm going to subtract 2 and 3 to get rid of x, and then 1 with one of the other ones. It doesn't really matter. Okay. So equation 2, I'm going to actually take equation 3 and multiply it by -1. Okay. So equation 2 is 3x minus 5y plus 4z is equal to 3. Negative 3x minus 2y plus z is equal to 0. We add these together. 3's cancel out. We're left with negative 7y plus 5z is equal to 3. And then in our other two equations, what we're going to do is I'm going to multiply equation 1 by 3. And I'm going to multiply equation, say 2, by 2, just so that we get the same coefficient. I multiply by the other's coefficient. Okay? So in equation 1, we multiply by 3, we get 6x minus 3y plus 3z is equal to 3. In equation 2, we multiply by 2, we get 6x minus 10y plus 8z is equal to 6. Now, I forgot to multiply by a negative, which is fine. We'll just subtract these two equations to eliminate the x. Okay. So we'll subtract these two equations. These cancel out. This becomes positive 7y. This becomes negative 5z. And this becomes negative 3. Okay. So here's our equation 4 and our equation 5 in this case. We're going to stack them on top of each other. 4 negative 7y plus 5z is equal to 3. And 5 equals 7y minus 5z equals to negative 3. Okay? Now, if I look at these, I can eliminate y by just adding. Correct? So let's add these equations together. This becomes 0y. But when I add these together, it becomes 0z. And when I add those together, it becomes 0 again. So essentially what we've come up with is a coefficient of 0 divided by 0, which is an infinite amount of solutions, which means we're dealing with a line in this case because we weren't able to find a specific point. So now what we have to do is we have to set a parameter in one of our equations. Okay? And let's set our parameter at z is equal to t to solve for a line, if you guys remember when we were doing that. So in this case, we'll set z is equal to t. Now, luckily, we've done a lot of the work, and I'm going to zoom out just a little here. If I set z equal to t, I've already eliminated x, right? So I'm going to take equation 4 and plug z is equal to t in for z, and that will give us our parametric form of y. So I'm going to take my equation 4 here that we had from before, so we don't have to rework anything. Negative 7y plus 5. Here we're going to plug in t for z is equal to 3. Okay, and I'll just zoom in so we can do that work there. We get negative 7y is equal to 3 minus 5t. So y is equal to negative 3 over 7 plus 5 over 7t. So that's our parametric form for y. We already know z is equal to t. We just have to do the same thing for x. Okay. Now we don't have an equation where it's just z and x, so we will have to plug into one of the equations above. Let's plug into 1. 2x minus y plus z equals 1. 2x minus y plus z equals 1. We have our parameter for z. We know it's going to be t. And we have a value for y. So we have 2x subtract negative 3 over 7 plus 5 over 7t plus t for z. So I've replaced z with t, and I've replaced y with our parameter is equal to 1. I did make an error. This should be an x. So now the only non-parameter unknown here is x. So we're going to isolate for our x. We'll distribute that negative 2x plus 3 over 7 minus 5 over 7t plus t equals 1. We'll move everything to the other side, so we have 2x is equal to 1. Subtract 3 over 7 minus t plus 5 over 7t. And we'll collect our like terms. 2x is equal to 4 over 7. That becomes negative 7 over 7. So negative 2 over 7t. Someone double check that fraction for me. And we divide by 2. X is equal to 4 over 14 minus 2 over 14t. So our parameter for x is this. Y was what we had above at negative 3 over 7 plus 5 over 7t. And z was equal to t. Okay? So this is the parametric form of our line. And if we want to convert it to vector form, just so it makes a little more sense, remember if our x, our y, and our z is equal to the coordinates, I'll underline red, our x coordinate being 4 over 14, or 2 over 7, our y coordinate being negative 3 over 7, and our z coordinate being 0, and our parameter of t, we underline our t values. For x, it's negative 2 for a direction vector. Y is 5 over 7. And t is the value of 1. So that's in vector form, our equation of our line.